Good evening friends, this is Professor Vishal and in today's session we are going to start our subject chemistry. Okay, so I am teaching you chemistry for 11th standard Maharashtra State Board, and in which I am going to start first chapter. That is, name of this chapter is some basic concepts of chemistry. Okay, so as its name indicates, this chapter is all about basics. Okay, we have to quickly revise whatever the terms or basic concepts we have studied in up to previous standard, that is 10th standard. We will quickly revise it and we will study these concepts in detail in this chapter. Okay, but before actual starting of this chapter, I just want to tell you what exactly the chemistry is. Okay, so as we all know, chemistry is the branch of science, likewise other branches. It is also the branch of science which deals with the study of matter. Okay, means what? Chemistry is this branch of science which deals with study of matter. Now here question arises then, what exactly the matter is, how we are going to define matter. Okay, matter is nothing but anything which is having weight and which occupies volume, which occupies some volume. That is we call it as a matter. Okay, matter is anything which is having weight and which occupies volume. That is called as matter. Okay, now we will see how this matter is classified then. Okay, now this we will going to write classification of matter. So basically, when we discuss about the classification, it is divided into two basic categories. First one is physical classification and second one is chemical classification. Okay, again matter is divided into these two types, physical and chemical classification. This physically, when we discuss about this physical classification, again it is divided into three subtypes. Okay. That is solid, or we can say solids, liquids and gases. Okay, physical classification, again matter is divided into three basic types: solids, liquids and gases. Okay, we will see these in detail. Then we will see, firstly we will classify. Again, this chemical classification is divided into two basic categories. First one is pure substance and second one is mixtures. Pure substances and mixtures. Okay, now we will see this classification in detail. What exactly the solids, what are the various properties of solids, how we are going to identify them, what is the difference between them. Then we will discuss about this chemical classification in detail, that is how these pure substances gets classified, how these liquids, solids and gases will further be studied, okay, in detail. So let us see classification of these pure substances. Okay, I will rub this and I will again use this board. We will in detail study the classification of pure substances. Okay, as we all know, according to the chemical classification, matter is divided into two types: pure substances and mixtures. Okay, I am discussing about pure substances. Okay, when we see pure substances, they are subdivided into two types. Basically, we call it as a three types. First one is elements and compounds. Okay, again these elements are classified into three subtypes. that is we commonly known as metals, non-metals and metalloids. Okay, now again these compounds are classified into two subtypes. First one is organic compound and second one is inorganic compound. Okay, so this is the classification. So here pure substances is classified into two basic types, elements and compounds, and then elements are subdivided into three types, metals, non-metals and metalloids, and compounds are classified into two types, organic and inorganic. Now here the question arises here, what exactly the elements are? Elements are nothing but the elements contains, we can write down here, atoms of, or we can say in element atoms or we can write this as the same types of atoms are there in case of elements, but in case of compounds different types of atoms are there. Okay, for example O2 is there, so it contains two atoms and both are from oxygen category, isn't it? So in case if you see H2O, H2 is a compound, so it contains two different atoms, hydrogen as well as oxygen atom. So in this way you can easily identify what is the element and what is the compound. Okay, now we will see firstly the detailed classification of elements, then we will see the classification of compounds. Okay, so I will drop this and I will again going to discuss this compound in our further part. Okay, now when we discuss about these metals basically metals are nothing but elements which is having luster, isn't it? This is the most important property of metal. Okay, then when we discuss about the metal the metals are generally having property of ductility, means what, they can be easily drawn into thin wires. Okay, they without breaking, that is most important. Then we will see the third property of metal that is they are having property of malleability, means metal, if we hammer with the help of hammer, if we hammer the metal, they can be converted into thin sheets, isn't it? So most of the sheet metal work are carried out with because of this property of metals only, isn't it? Generally aluminium we have seen, or what we can say, the surfaces of our automobile, so they are generally due to this malleability property, isn't it? Then we can say the most important property of metal is they are having high boiling point, and high melting point, isn't it? Then most important properties, they are good conductors of heat and electricity, good conductors of heat and electricity, I can say, isn't it? I'm going to write in a rough way, but these are the properties which we have already studied in your last standard, but I'm just quickly revising it. So which is most important again. So in this way these are the basic important properties of metals. Okay, though if the element showing these properties, we can call it as a metal, but the most important property with the help of which we can identify the element is metal, that is luster. Metal is having luster, though there are some exceptions, but in general these properties are important in case of metals. Okay, now what about non-metals? Generally see, non-metals are non-lustrous. Okay, they cannot be drawn into thin wires, so there is no ductility. Generally non-metals are brittle in nature. If you try to convert them into wire, they will break down, isn't it? Like glass type structure is there, isn't it? Then they are also non-malleable because they cannot be converted into thin sheets. Then non-metals are generally having low boiling and melting point. So with reference to these properties, you can easily remember these. So we have seen about the metals. Now metals and non-metals, and metalloids are the elements which are showing the property of both metals and non-metals. Okay. Now after which common example of metals, as we already discussed, sodium, gold, silver, ferrous. Then in case of non-metals we can say bromine is a non-metal, then carbon is a non-metal. In case of metalloids, generally bismuth, arsenic. So these are the non-metals. Okay. Now when we discuss about the compounds, compounds are classified into two basic types: organic compounds and inorganic compounds. Okay. Organic compounds are the compounds basically which are obtained from living things. Okay. And we can say the common example, the oxides of hydrogen, oxygen or nitrogen, they are generally organic compounds. Okay. Now we will focus in this session about non-organic compounds basically. So when we discuss about the non-organic compounds, the more important source from which we are getting non-organic compound is the earth crust, or basically non-living things. Okay. So these are the some of the examples of non-organic compounds. I'm just try to write down here the chemical formula as well as chemical name of that compounds. Most of the times we have to use these compounds in most chemical reactions. So in detail I thought it is useful for all of us. Okay. So when we discuss inorganic compounds, first example is a NaCl, that is rock salt. We commonly call it as a rock salt, that is NaCl. Then second example, if we see Na2CO3 Na2CO3 10 times H2O, that is washing soda. We call it as a sodium bicarbonate, isn't it? Then third example, NaHCO3 baking soda, sodium carbonate. Okay. Then fourth example is Na2SO4 10 times H2O. We commonly call it as a globular salt, isn't it? Globulous salt, we can also call it as a globulous salt. Then CaCO3 is a calcium oxide, isn't it? This is also one of the important organic compounds. CaCO3 calcium carbonates, then CaOH2 calcium hydroxides. So these are also important inorganic compounds which are used in most of the chemical reactions. Then CaSO4 2 times H2O, that is gypsum. Then CaSO4 half H2O, that is plaster of Paris. We commonly use for making the for decorating purpose, for interior design works, as well as for sculptures, as well as for idols of making Lord Ganesha and Lord Durga and all such idols. So we are using commonly plaster of Paris. Okay, so these are all nothing but the inorganic compounds. Now further we will discuss about, this is all about chemical classification, isn't it? Now we are interested to know how matter is classified into physically they are how they are classified. So we just wrote down their names. Now we will we will see in detail. Okay, basically according to physical classification, they are divided, matter is divided into three basic types, as we all know: solid, liquid and gases. Okay, now we will see one by one each of them. So when we discuss about the physical classification, I'm going to write down here. So this type of classification are basically okay, after chemical classification we are going to discuss about physical classification. Okay, as we already discussed, physical classification, according to physical classification, matter is divided into three basic types. First one is solids, liquids and gases. Okay, so when we discuss about the solids, so atoms in the solids are arranged like this. Okay, means what? There is no intermolecular space between them, or very low intermolecular space between them. They are closely compact. Okay, hence what will happen? Intermolecular force of attraction in case of solid is too high. They will closely packed with each other. Okay. Then when we discuss about the solid, most important property of solid, they are rigid. Means after applying force, their volume does not change easily. Okay, in general they are rigid in nature. This is all about solids. So these three parameters are most important when we study the solids. Okay, now what about second, that is liquids? When we see the liquids, the molecules are, there is a space in between them, or intermolecular space is more compared to liquids. So compared to solids, in case of liquids, intermolecular space is somewhat more compared to solids. Okay, and hence what will happen, the intermolecular force of attraction in case of liquids is a low, or we can say there is a less intermolecular force of attraction compared to solids. Again I am comparing this all these properties with respect to all these parameters with respect to solids, because see what will happen when we study the liquids, intermolecular forces are there. When we compare the same parameter with solids, they are less. Okay, and most important property is what? Fluidity. They can easily flow. Then third, according to the classification, third type is gases. Okay, basically gases, as we see, the molecules are very dispersed in nature. The distance between them or intermolecular space is too high in case of gases. As this distance is high, there is less intermolecular force of attraction in between them, and hence they can, what we can say, the most important property of gases, they are incompressible. Sorry, they are compressible, or compressibility is there. Means what? When we apply the pressure, its volume gets changed, isn't it? So, and while changing the volume, what will happen? Temperature rises, isn't it? So in this in case of gases, compressibility is most important. In case of fluid, in case of liquids, fluidity is important. In case of solids, part of concept of rigidity is most important. So in this way we have seen the classification of a matter, physical as well as chemical classification. Okay, now we will see further two important properties of matter, that is fundamental property and derived property. Okay, so we will see these two properties. First property, or we can firstly write properties of matter. Okay, first property is a fundamental property, and second one is derived property. Okay, now as its name indicates, fundamental properties are the properties which are nothing but the own properties of the matter. We called it as a own properties of matter. Okay, so there are basically total 7 fundamental properties. 7 properties are there. We will study them one by one in detail, and basically derived properties are the properties, what we can say, which are, as its name indicates, they are derived from fundamental properties. Okay, and basically we can write down, there are various derived properties which are based on the fundamental properties. I will give you one example, and then we will see fundamental detail and derived in detail. Okay, so for example, mass is the fundamental property. Okay, so when we discuss about this mass is fundamental, means what? Mass is the own property of this matter, hence it is fundamental property. Now when we discuss about density, let us say density is equal to mass per unit volume. Okay, so if I want to calculate the density, I need mass, isn't it? And mass is what? Mass is the fundamental property. Hence these all properties are derived. Basically they are derived from fundamental properties, hence they are called as derived properties. So this is one example. We will detail study the 7 properties first, and then we will discuss about the derived properties. Okay, so when we discuss about the fundamental properties, there are total 7 properties, as I already told you. I will write down it one by one and with their units also. Okay, so first fundamental property is a temperature. Okay, so second one is mass, third one is length, fourth one is time, fifth fundamental property is current, Sixth one is the luminous intensity. And seventh one is the amount of moles. Okay, so if we see all these properties, they are fundamental in nature. They are the own properties of the matter. Okay, for example, if I will take temperature is the own property. Then mass of the matter is always there. Okay, we need not derive from some other units. Then length is also fundamental property, time is also fundamental property, current, luminous intensity, and amount of moles. So they are all 7 fundamental properties. All these derived properties are based on this property. Okay, so they are the own properties of matter. So when we discuss about the units, temperature is generally measured in Kelvin, isn't it? Say 0 degree centigrade means 273 degree Kelvin, isn't it? Similarly, mass is measured in kg. So there are various units. I am discussing about SI units first. Then length is generally measured in meter. Okay, again measurement of length can be depends on application. Units are depend on application, isn't it? Kilometer, meter, millimeter. If we take the mechanical applications or mechanical engineering drawings, generally all dimensions are given in mm, isn't it? Then time unit for time is second, isn't it? So then current is generally measured in ampere. Luminous intensity, unit of luminous intensity is candela. And lastly, amount of moles are generally measured in moles, isn't it? So for example, if I am having 2 moles of ammonia, then I can say this is moles. Okay, or 2 times H2 means what? This 2 is nothing but the moles. So these are the 7 fundamental properties. Okay, so after this we are going to study derived properties. Okay, as its name indicates, these properties are derived, or I can write here again. As its name indicates, these properties are derived from some other properties, that is, they are derived from fundamental properties. Okay, so here I can write derived from fundamental properties. Okay, now for example, as I already given you the example, I will again take one more example. For example, if I want to calculate volume. Okay, so this is, let us say, your first example. For example, a cube is there having side L, and I am going to calculate the volume. So formula is what? Length cube, or we commonly call it as L cube. Okay, now when we discuss about this length is what? Length is fundamental property. So we can say that volume, if I want to calculate volume, I need fundamental property as the length. Then I can calculate the volume. So volume is what? It is a derived property. Are you getting? Okay. Then we will see one more example. Let us say density. I am taking the example of density already. I will repeat it again. For calculation of density, formula for density is mass per unit volume. Okay, again, if you see, if we will write the unit kg per meter cube, this mass is again fundamental property, and for calculation of volume I need length. So length is also fundamental property. So without using these two properties, I cannot calculate the mass density, isn't it? Hence mass density is what? Derived property, which is based on fundamental property. Okay, then we will see third example, that is force. Force is what? Force is equal to mass into acceleration, which is equal to ma. Again, if you see, mass is a fundamental property, and acceleration is what? Acceleration is nothing but the rate of change of displacement with respect, sorry, rate of change of velocity with respect to time. So time with respect to time means time is a fundamental property, isn't it? Hence acceleration is also depend on fundamental properties. So these two terms are dependent on fundamental property means what? If I want to calculate the force, I need fundamental properties. So this is what the derived properties are. Okay. Now we will see one more example, that is example number 4. In this case, let us say if I want to calculate work. Okay. Now work, formula for work is what? Force into displacement, isn't it? So force, as we already discussed, it depends on mass and acceleration, and they are depend on fundamental properties, and hence work is also depend on fundamental properties, we can say. And if you see the displacement is generally measured in terms of length. Again, length is fundamental property. So in this way we can say that work is also derived quantity or derived property, isn't it? So these are the 4 basic examples. There are various derived properties which we for calculation or for calculating the derived properties or for derived quantities, we must know fundamental quantities and their units. Okay, so this is all about the basic properties of matter. 2 properties, fundamental and derived. Okay, fundamental are the own properties of matter, and derived are these are the properties derived from fundamental properties. So these are the examples: volume, mass density, force, then work. So for calculation of these parameters we need fundamental properties, hence we call it as a derived properties, or we can say these properties depends on fundamental properties, hence they are called as derived properties. Okay, now we will see afterwards measurement in chemistry. Okay, so next parameter is measurement in chemistry. So generally we are using some scientific notations. For example, if I tell you, I just want to write down, so this is a number, let us say 0.00004. Okay, so conveniently I can write it as a 4 into 10 raised to 5. Okay, so why I am writing this in terms of power? So because this is what the way of writing down it scientifically. Okay, so how I am going to write this? Because see, just this I am going to shift this decimal point after this, means what? 1 2 3 4 5. I shifted this decimal point towards right with 5 digits. Okay, so anything towards right, if I will shift, I have to subtract the power. Okay, so means what? 4 into 10 raised to minus 5 means 0.00004. Okay, so means what? I am shifting, if I am shifting the point from left to right, okay, then I have to subtract the power. Okay, similarly if I am using let us say I am going to take this example, 50,000. Okay, and here in this digit or in this number, point is at this position. If I want to write this 5, okay, means what? I am shifting this point at this location. So just count the numbers and put the direction A1 2 3 4. 4 numbers I am shifting in leftward direction, means what? I am reducing the number, so I have to increase the power by 4 digits, because I am shifting the decimal point you by 4 digits. Okay, so in this way you can write down the particular numbers by scientific notations or scientific methods. We commonly call it as scientific methods. Okay, so we will take one more example. Let us say 942.65. 942.65 into 10 raised to minus 4 is given. Okay, so let us say not minus 4, plus 4 is given. Okay, and just want to shift this point after this 9. Okay, so I can write this as a 9.4265. okay, and as I already told you, if I want to shift this point in leftward direction, I have to add the power by how much? digit by the digit which I am shifting. So here 1 and 2 digits, so I am shifting. As I am shifting towards left side means I am decreasing the number, so I have to increase the power. Okay, so plus 2. So in this way you can plus 2 means what here, sorry, that 10 raised to 4 is already there, plus 2 means 10 raised to 6, isn't it? Means we can write 10 raised to plus for 10 raised to 4 plus 2. So I can comfortably write as 9.4265 into 10 raised to 6. So in this way you can write this number. Okay, I will take one more example, it will be clear for you. Let us say 0.0096 into 10 raised to minus 4 is given. Okay, and if I want to shift this 9.6, okay, means I am shifting this point by 3 digits and I am traveling towards right side, means what, I am increasing the number. So if I want to increase the number, I have to decrease the power, but already minus 4 is there, then minus 3 is there, isn't it? I am shifting the power, so I have to subtract it, then it becomes 9 raised to minus 6 into minus 7. So this is what the scientific notations we are using. Okay, so it will be helpful in chemistry as well as physics and mathematics. Okay, so after this scientific notation we are going to see the next important parameter, that is significant figures. Okay,